to lead us up with his project called Furthering the Natural Language Processing Capabilities of Humanoid Robot Pepper through Application of RLHF. I'm excited to learn about this. It'll be cool. Siddhartha is going to present, and then we'll have questions at the end. And you can start whenever you technically have 2 minutes, though. So, yeah.
Hello everybody, my name is Siddhartha Shibi, and today I will be presenting to you about furthering the natural language processing capabilities of humanoid robot Pepper through the application of reinforcement learning with human feedback. I'm a research intern at Purple Grid Sync as well as Intel Science Training Institute. So first, let's talk about the subject of this presentation. This is Pepper, a robot developed by SoftBank Robotics in 2014. Pepper is designed for human interaction. You can see it from the various expressive motions and from the 20 different degrees of motion it has from its head to its fingertips, and additionally the emotions it can detect with its cameras. It also has multilingual support for over 16 languages and multiple perception modules and 2D, 3D cameras, which keeps it aware of the environment around it. And while Pepper is so well designed and engineered for the aspect of human-robot interaction, it has one critical flaw, and that's the fact that this robot does not contain true intelligence. Pepper's intelligence is on device, meaning that much of what it's able to converse with or speak is either pre-programmed or just based off of specific keywords which it knows already. So one way we can give it much more natural speaking capabilities is by integrating LLMs or large language models. By introducing this external source of natural language processing, which depicts the way which human brain's neurons work. Through this interconnected system, we can apply this sort of knowledge to the Pepper robot, giving it capabilities such as logical reasoning, continual learning, and being able to understand nuance, for example, like sarcasm or double-sided meanings or humor. So, in order to apply this change, first we need to understand behind the hood how does Pepper work? Well, you can break it down into 5 base modules. You can see from the very microphone detection, which picks up this text and recognizes it, to the AL dialogue, which manages this flow of conversation and provides the responses, which it'll speak out through its text-to-speech. And the key critical area or weakness, that is its inability to provide this free-flowing motion, is the AL dialogue. Another key area of improvement is the speech recognition, which is limited by its own hardware. So how can we address these issues? The way which we decided to approach it is through integrating an NLP in this AL dialogue module, using an LLM such as Google Bard, which can take care of this, take care of understanding this text and providing the response, in which the robot would act as a medium to convey through its gestures and its text-to-speech, giving it life. How exactly can we take this LLM's output and take over the robot's own logical processing? Well, we use this chat adapter, which connects to a chat server, and by this method, we are able to both store past conversations within an external chat database, giving context in conversation, so the robot's able to recall the thing you just said and add more information relevant to it. And it's also taking these responses from Bard, or you can choose a different LLM based on the intents and purposes of the robot itself. And from there, again, the robot will convey that. It's all dependent mainly on the LLM's own processing. However, while this seems like such a great solution, having an LLM to take care of all the busy work giving this robot supreme intelligence, right? The problem lies, LLM problems are robot problems. So whatever problems an LLM can face, the robot will face. Two major problems, one being bias, the data which the actual LLM is trained on, is one crucial factor which can play in these responses. However, there's also the possibility of hallucinations, meaning the robot might conjure up some sort of makeshift response which is not grounded within reality. And these two issues are problems which still plague modern LLMs today, and does affect Gen AI. But the approach of the current research for this presentation is applying reinforcement learning. So reinforcement learning in basic is a process which takes an initial large language model and its tuned counterpart, and by analyzing the differences within it and adding the corresponding weights and balances from the reward model, we can re-update the tuned model itself. Essentially, through this feedback loop, we can make the LLM much more competent, and it can take care of some of these inadequacies. So one particular method, which I refer to as the static method, is by applying supervised fine-tuning, where we'll have the LLM generate 4 sample responses to a prompt. And the scenario is we have a panel of expert human judges, and these people will determine which of these responses is best and rank it in a hierarchy. And this sort of feedback is what will be sent back as this sort of fine-tuning. And in this sample scenario, you can see that out of A, B, C, D, C was the best choice. So given that, this information is what will be sent back to the actual training. And this is handled mainly in the pre-training aspect of these LLMs, which are before they're either commercially in use with the end user. So it is a valid option for taking care of problems or issues ahead of time. However, this does not counteract for certain things which can happen in the field when you're actually talking with a human observer. So that's why I decided to design a more dynamic approach. And the goal of this is to capture a person's human emotion, and from there use that instead as additional feedback. So if the robot said something which might seem wrong or inaccurate, a person's face can tell a lot of information, and their response of being like more neutral or sad can give this sort of crucial feedback which is needed urgently for the robot to actually act upon. And the actual implementation of this is quite simple. We start off by obtaining the picture of the person's face, and with this we can use Python's deep face library, which is quite simple and lightweight in analyzing these images. And while it can detect a multitude of different features from age, gender, race, the key one of focus is the emotion aspect. And by using this, of course, there's multiple models. We decided to opt for OpenCV. We can accurately depict some of the few emotions which it's able to detect. So just the general gist of the programming, we just load up the model and extract the features and just return it back. And the actual output of this research was, here's an example. So without this sort of fine-tuning, when speaking to the robot, you might ask a question like, or a statement saying, "I lost my passport." Now, generally, if you ask this to some sort of AI or LLM, it will provide a response quite akin to this one, which is reported lost or stolen immediately. And of course, this is very quick, firm, and it goes to the point. However, in this sort of scenario, with the intensity of the situation itself, there might be needing more care or more empathy in its words. So with this sort of fine-tuning, applying both the supervised fine-tuning, which gives us this humane aspect within the AI, as well as this emotion recognition, which can depict the person's fear or sadness, we can get a response which is much more compassionate and ethical, which says something like, "I'm sorry, is there anything I can do to help?" And it gives off a much more comforting or warm vibe, which is much easier for the person to interact with the robot. Some of the future work which this project aims to integrate is tone of voice. For example, someone's voice could waver or stress certain syllables. And picking up on these small things is, of course, something which is a much bigger task. However, of course, it all plays into the role of getting these certain emotions. Additionally, it's improving this emotion recognition process because it's all dependent on the image model itself, and handling this across a server, taking different alternatives to make it faster and efficient, and perhaps maybe on device itself can give it much more possibilities. Aside from that, another thing which I'm looking forward to working on is the automatic validation of outputs. So, as I've mentioned before, there's the possibility for bias or hallucinations, and these are still common problems today. But by evaluating responses with some of these key values, such as how correct the responses are fair, relevant, and whether they're actually grounded, having an automatic way to judge this is much more efficient, as opposed to having a panel of people constantly review these values. That's my presentation. So, thank you all for listening.
First of all, the presentation was really good. I think the way you presented things with the pictures and everything from people who have a machinery background, that was awesome.
Thank you.
I'm gonna go ahead and ask a question.
Okay.
I know you're gonna work on this thing, but maybe you know. So I'm just curious about this. I know LLMs right now. Well, so like if the robot, you're saying that if I talk to the robot will respond back to me.
Yeah.
How does the robot like perceive what I'm saying? Like how does the LLM pick up the words that I'm saying? Like what's the hardware? What's the algorithm behind it?
So as of right now, the actual speech recognition, which is translating your actual speech to this text, is handled by the robot. So that's one of the. Actually, I can go back. Right over here. The speech recognition module, that's what's handling the brunt work of this. So it is something which can be improved later on by sending this like voice file or text to an external sort of speech recognition processing. But as of now, we're just using the default like on-device robots. It's built within the robot itself, so it already processes it into text. So just creating an Android application and just retrieving that, we can send that off to the actual LLM.
You mentioned that there's bias. They were considering that. I might have misunderstood this, but how the programming is being developed, or the bias of the robot, like what are you doing? Maybe explain that a little bit more. But what are you doing to mitigate that bias?
Okay.
Do you know what I'm saying?
So the bias in question, I was referring to like bias in data. So a lot of the data which it's trained on is, of course, can be consumed like popular media, for example, and just a lot of these things which people might imply to be common sense or whatnot can be reflected within these AIs. I think one example which I saw a couple of years back was when ChatGPT was asked to generate like images of like doctors. It would typically generate male doctors. So that was a sort of bias which can be seen within this. And the approach to sort of counter this is there's another method which I'm also looking into, but the current method of evaluating this is both through the supervised fine-tuning, which sort of like filters through these different responses and picks out the best one. And by doing this, we can sort of like remove out like some of the other obvious biases, which can be just accidentally put in this data. And it's this process which over time will sort of clear out these different biases. And the actual reinforcement learning with this emotion detection is more of a method to sort of counter like the person's actual response to this robot. Because if the robot is saying something and it's actually somewhat concerning, or if it's not taking into matter like current events or something, then that emotion is like a last barrier sort of thing, and that's what can counter it. An additional thing which can be applied is RAG. So by using retrieval augmented generation, we're essentially getting this like constant new data which is fed to this robot, and we're just telling it not to hallucinate and not make stuff up. Then now that it has this new information, it can refer to that as opposed to making up some numbers or statistics, which is another way you can sort of counter these hallucinations and bias.
Cool. Well, if you have any other questions, you can chat with Siddhartha after, but we're going to move on to our next presentation. Thank you so much.
Thank you.